All right. And I know the key was out, so you probably already know how this ends, but maybe there are certain things that I can just make you aware of. For example, MPH, miles per hour, that's what that stands for. So I don't know if you, that's more like an American thing, right? If you go to US, their speed limits are miles per hour. We want it to meters per second, right? So you start 65 miles in 1 hour, and your goal is to get to meters per second. So my key is probably going to be different than the way I do it right now. I'm notorious for that, but that shows you that there's not just one way of doing things, right? So going from, I'm going to tackle and try to get miles to meters first, and I'm going to put hours on hold for now. Just going to focus on converting that to meters. What do I have? I'm going to go to my rates here. I have that 1 mile has 1.6093 kilometers. Right, that's one. So, oh, I made a mistake, didn't I? Big mistake. What's wrong with this? The miles have to be in the denominator, right? So they cancel out. So, my bad. You're lucky it's on Monday morning, because that's when it's really bad. 1.6093 kilometers. So miles go with miles. And the one that you should all know, right, is that 1 kilometer, right, this is going to cancel out here as 1,000 meters. Okay, so at this point, if you look at the miles turned to meters, now I'm going to tackle the hours, okay? And I want it in seconds. So I will say that 1 hour, which you all know, I think you would all know that 1 hour has 3,600 seconds, right? Yeah. Do I have, I feel like I might have given you that rate. Do I have miles to meters right away or no? No. But if you did, that's fine. Yeah. So what you're referring to is just writing this out as 1,609.3 meters. Yeah, that's fine. No problem. Yeah. So hours go with hours. And at this point, if you need to have this rate on your study sheet, go for it. The chances are you're going to need that, right? 1 hour has 3,600 seconds. 60 minutes, right? 60 seconds, so it's 60 times 60 gives you this. And now we're ready to go. But I would highly recommend to just multiply the tops, right? All the numerators, and you get that. And then 1 times 1 times 1 times 3,600 is just 3,600. So technically, right now, you're traveling this many meters for every 3,600 seconds, and we don't like it like that. You want a 1 down here, right? So you dividing it is the way to accomplish that. So it's 21 point, at this point, you'd round to 2 decimals, right? So 29.06 meters per second. That is your speed there. Hey, I got it right. So that's your answer for this, the conversion. Obviously, there's a lot more here than some of the other ones, so it obviously would be worth more. Can I just say something else? This is what we would call a rate. All of these actually are rates, but when you have a number over 1 second or for every 1 kilogram or whatever, that's called a unit rate. I don't know if you've heard that before. Okay. Unit rate, it's because there's really a 1 second for every second, right? So you're reducing it to just a unit rate. So we'll see that again later on. And I'm going to erase the homework here to use that space to answer the next question. So when you're converting, you want to multiply like this and always have them opposite to each other so you can cancel out. Now, when you're given a question like this, how long would it take to travel 750 meters, right? They give you partial information. You want to set up a proportion. I'm going to use this speed. You could use that one. They're actually both of these are saying you're traveling, they're the same speed, just in different units, right? So I'm going to use this one, right? 29.06 meters for every 1 second. And then over here you would have 750 meters. You actually line them up when it's a proportion like this. You're asking how many seconds would that be? Like that. I don't know if you remember the shortcut. This is a shortcut. I have to say that because I know that you probably learned to cross multiply, right? Across and then you divide. It does the same thing here. You start where the variable is, you go with a number, you cross multiply, and then you divide. Right, 750 meters times 1 second divided by 29.06 meters. And so the meters will cancel out here, as you can tell, and you're left with seconds. So you divide like that. That's 25.81 seconds. That's, okay. Oh, I did add this bubble here for you, right? Yeah, that wasn't on my original, but mph is miles per hour, mpg is miles, miles per gallon. Yeah, sorry. And this is something that we use. They use in the U.S. to measure how much fuel your car uses to travel, right? So it's a fuel economy essentially. So the rest, I'll just leave that for you to do. Same kind of scenario. You just have to find the appropriate conversion rates to get from one to the other. Now, let's go back to the first page here. I skipped that yesterday. And right here, these ones deal with areas, and this will be volume. Okay, so you will notice that you have square meters there. And I'm just gonna say, if you wanted, basically, if the question asked you like a meter, how many square centimeters does it have? You couldn't just say, you would probably say 1 meter has 100 centimeters. But right now this is square units, this is linear right now, it's just centimeters. So what we need to do to this side is squared as well. Okay, so 100 times 100, right, you end up with 10,000 squared centimeters. And so for a yard, let's say, normally you would say 1 yard has 3 feet, correct? But it's not just yards, it's squared yards. So we need to square this whole thing. Okay. So 3 squared is 9, and feet squared, we just write it like this. And this is kind of to prepare you for next year as well, where we're not just going to convert linear dimensions, we're also going to convert areas and volumes. So 1 square foot, you would normally say, hey, 1 foot has 12 inches, but that's not accurate because now we're talking a square foot. So what you need to do with this, the 12 inches, you need to square that as well. So 1 square foot has 144 square inches in it. We're talking area, right? We're not just talking a linear dimension. Same with volume. I will use the exact same conversions here. So if you wanted, for example, to go from meters to cubic centimeters, well, we need to, knowing that 1 meter has 100 centimeters, we will just cube it and come up with our answer. Same with yards. 1 yard has 3 feet, but now we need to cube it to match the units on the other side. 1 cubic foot has 12 inches cubed as well. And here you have it. You'll have 6 zeros because you're multiplying 100 by itself 3 times. Now, 1 cubic yard is 3 cubic feet, so 3 times 3 times 3, that's 27 cubic feet. And then 12 times 12 times 12, that's 1728 cubic inches. I would say make sure you add these ones as well after today. Ideally, I would say you don't really need to, because you could just deduct it from this table, right? You could just come up with these yourselves, but it doesn't hurt if you have the space to just have these done and you don't need to bother actually cubing or squaring anything and possibly making a mistake. Anything else that I throw at you, I will give you that conversion rate or the conversion factor. We're going to practice one question that involves this. So we're going to go to page 4. We're good here? Page 4, we're going to deal with J and K at the bottom of page 4 here. So here you have 35 cubic yards, right? Maybe let's make note of that, right? It's cubic yards. And you want to turn it to cubic feet. Okay. And also we want to go from hours to minutes. Okay. So how would we do that? Exactly the same way as before. Remember, this is a rate, so you need to write the whole thing down like this. And let's deal with the cubic yards first. 1 cubic yard, what is it again? I'm going to have to peek. 9 times, so that's 27, right? Yeah, 27 cubic feet. So that takes care of the cube yards. That's gone, and we have it the way we want it. And then we know that 1 hour has 60 minutes. Sorry. Get your act together, right? Do it right. 1 hour has 60 minutes. And so cancel, cancel. And so now you're left with cubic feet and minutes. And don't rush. Right, so we're going to go 35 times 27 times 1, obviously, but that's irrelevant in this case. So you have 945 cubic feet, and at the denominator is 1 times 1 times 60. That's just 60 minutes. And now we divide. 15.75. It's actually finite. Don't need to round here. Cubic feet per minute. It's the equivalent. I want you to try K just try that one before we move on. Make sure you cut it here so you have enough space and start way on the left, right? So you have enough space to continue. And that's all right. K is probably was probably trickier than you thought. But remember, this part, attempt every question. Just give it a try, see how it goes. And I wouldn't erase just yet because you might have done it a certain way, you still come up with the same answer. So here we go. 600 square feet in 1 minute. And you want to turn it to square centimeters. I don't know if you probably didn't have one that got you straight from one to the other. But if you looked at your conversion rates, the one that got you closest would have been feet is equal to 30.48 centimeters, correct? There's just a slight problem with it that it's not squared yet. We're going to have to do something with it. So I'm just going to copy that one over, and I'll start like this. 1 foot has 30.48 centimeters. Did I get that right? Yeah, okay. And so right now you can't use it as is. So what you need to do is you need to square this whole thing. That's your ticket out of that problem. I won't do any cancellation just yet. Okay, I'm just going to leave it like that. But that's going to solve that problem. And then I'm just going to say that 1 hour has 60 minutes. Okay? So these minutes here will cancel out. That's for sure. But this part here, I will just use my calculator and rewrite this whole thing one more time. So watch this. 600 square feet. Technically, the 1 is gone here. And you grab your calculator and you will get one of these very soon. You square that. And I don't want you to round. You only round at the end. Right, it's this many square centimeters, and you have a square foot at the bottom because the 1 square just stays 1, right? And then you go 60 over 1 hour. And now we can cancel, right? We can go cancel that square foot with this square foot, and you're left with centimeters squared over an hour. Okay. And maybe I will use my highlighter here just to emphasize, right, the fact that you squared it. Okay. I'll make a note here. Square the rate. Okay. And so here we go. It's basically just 600 times this times 60, because in the denominator, all you're left with is 1. Okay. So we're just going to go 600 times 9 point, oops. Watch what I can do with this calculator. I can go 600, you're going to do this in a bit, times, you just go arrow up, and you copy that number down. You hit enter. It plugs it right in there, and times 60. So I'll teach you all of that in due time. That's squared centimeters per hour. There you have it. So here I gave you had this. We didn't need to cube anything. Here we had to square it so that we could actually go ahead and cancel out the units. Most of the time, these ones, you'll be able to just pick it from your list if you have it. But sometimes, be prepared for the unexpected. All right. We're going to continue on. So you might ask, what about all of this, right? What's up with this? The key is posted, right? So if you ever need to prepare for an AC or quiz, you go back, try some of those, the key is up, right? So I want you to have practice material, and it's all here. You don't have to like flip through the textbook, find a section, it's all right here. You're good to go. All right, let's keep going. So really this is not going to be completely new. We're just adding word problems now. And that's basically the theme in this course, word problems. Okay, but I'm going to prepare you for that. But it basically boils down to converting and then extrapolating, which means like you need to convert your units to what you want it to be and then like predict what's going to happen in the long run. And it's essentially converting and then setting up a proportion. That's basically what this is. Okay. So once given a rate, you can use it to set up a proportion. That's basically two equivalent fractions with an equal sign in between. Okay. So here we go. A car travels 50 kilometers per hour. Right, this is rate. This is a rate, by the way. How many miles can it travel in 7 hours? And what's the problem here? There's the miles part that is, you're going to need a different unit. So you choose, do you want to convert that rate right away? Or do you want to convert it later after the proportion? It doesn't really matter. Okay. So I'm going to convert right away. Convert to miles per hour. That's what I'm going to do. So we have 50 kilometers per hour. We know that 1 mile has 1.6093 kilometers. That's all I need to do there, right? Because the hours, I want to keep it to hours. You follow me, right? Hours is like, I want to keep it like that, so I'm not going to convert, but this is going to cancel out. So here we go. It's basically 50 times 1, which is 50. I'm just going to stick with it because, and now I'm going to divide. So 50 divided by 1.6093, that's 31.0694. So if you round to 4 decimals, because your calculators aren't as fancy as mine, and I don't want you to, but technically this keeps going. But if you use 4 decimals along the way, you're going to be okay. Right? So that's this many miles per hour. And then this is the extrapolating part. Predict. So if that is true, right? So if we travel 31.0694 miles per hour, sorry, come on, I'm too nervous, guys. Calm down. This many miles in 1 hour. If you ever find yourself stressing, just calm down, take a breather. We want to know in 7 hours, how many miles are we going to travel? That's what we want to know. So again, to find x, to find the number of miles, we start with the number, cross multiply, divide. So it's 7 hours times 31.0694 miles over 1 hour. And the hours cancel out just like that. So we're left with miles. So I'm just going to grab this number, copy paste times 7. So it's 217.49. This is where I round. Okay, 49 miles in 7 hours. You could have first done the proportion. I'm telling you already, you would have come up with 350 kilometers, 7 hours times 5, right? And then you convert, you still come up with the same answer, right? So it doesn't really matter. Sometimes you'll prefer one over the other. Okay. I think I'm gonna just leave you with this. You want to write down the answer in case you want to practice, because I have more. I want to get a little further than this. So if you want to practice, it's 2.53 gallons that you would use and that the motor would need in 12 hours. I think when it comes to rates, I'm going to scroll down to the bottom of this page. I need you to highlight this part because some students do some interesting converting when they're answering question, but it's not always quite right because they're mixing things up. So when money is involved, right, money, then I want you to have cost over quantity. So maybe I should say it differently, right? Money over quantity. You can't see that, can you? There you go. How's that? So money always goes on top. How's that? We all think of money, right? We like our money. That goes on top. And then put everything else at the bottom. Pounds, whatever it is, liters, you put it at the bottom. Because some students do it the other way, and then you're actually finding, how many dollars for the pounds, and that's just not, it doesn't make sense. So this is the way to go. This is kind of like the standard way of doing things. And I would also say speed is always distance over time. Okay. Here's the fuel economy part. There will be for sure one fuel economy, if not two, that you will come across. And it's the fuel used per distance. And it's usually liters per 100 kilometers. But it could also be miles per gallon. It could also be stated, right? And here's a new concept. Determining a better rate. Convert to unit rates, right? Units need to be the same. Maybe I'll use a different color here to emphasize that point. Units need to be the same. Determine the unit rate. You go numerator divided by denominator. Then state the better rate. And usually I'm going to ask you by how much. By how much is this one better than the other? So sometimes you're going to have, 350 for 5 pounds, let's say. A unit rate, to get it to a unit rate, that's what you really want, you would go 350 divided by 5. That's really what you would do. Okay. And that's 70 cents per pound. This is where it's at. This is what you want to use to compare to another product. Okay. Most stores are getting pretty good at that. Produce or anything, they'll give you the price per 100 grams or per pound or what have you. And so that's how you really compare one over the other. Because sometimes apples come in 5-pound bags, sometimes they come in 3-pound bags, right? So it's like different weights, like which one is really better. Boil it down to how much is it per pound. Cost divided by quantity. Okay. So next time you go shopping, you help your parents out, right? It's like, no, no, I got this. Money divided by quantity, and that's so if you do this for all the products, the one that is the lowest is the better one, right? Obviously, sometimes it comes down to the brand and whatnot, but if it's only money, this is how you would come up with the best product to purchase, right? Let's keep going. So here we go. Which is the best buy and by how much? Is it buying a 12.8 kilogram turkey at Safeway for this much, or buying that same a turkey at Superstore for $1.49 a pound? This is already a unit rate. Okay, I really don't want to touch this, so I'm just thinking out loud. I'm thinking, okay, I need to compare. I need both unit rates. This one is already a unit rate. Already a unit rate. So why would I convert that, right? It wouldn't make sense to do any conversion there. So I'll just say this. I will do some work with Safeway. Okay. And what do we know? Well, we know that 12.8 kilograms, I'll just do this here, for 42.89. Okay, we know that. What goes on top every time? Money, right? Money. So I'm going to start like this. I'm going to say, okay, 42.89 for 12.8 kilograms. Is that a unit rate? Not yet, is it? If I divide them, then it's a unit rate, correct? If I were to divide, if I go this divided by that, I would have a unit rate. But the problem is this is per pounds, right? So let's go Superstore. It's $1.49 per pound. So I want this in pounds. Wouldn't that make sense, right? To first do you converting first and then come up with your unit rate. So this is what I'm going to do. 1 kilogram has 2.2 pounds. You could look that up if you don't trust me, but you should always look it up. Just I'm like Dory, I forget everything in seconds. Okay. So this ends up being 42.89 over, we multiply this, 12.8 times 2.2. I'm going to use the calculators that you're probably using right now, okay, to keep it fair. Right? So what did I just do here? I first converted, right? Convert to pounds. Okay, that's my first order of business because Superstore had their price per pound, so I just first wanted the price for this many pounds. Now I'm going to turn this into a unit rate. Okay, so I take 42.89 divided by 28.16, and it is 1.52. Sometimes you have to round to 3 decimals. If both of them are the same after 2 decimals, keep going. But 99% of the time, 2 decimals will do the trick. Okay, so this is $1.52 per pound. Now we're talking. Now you can say, okay, I have them both in the same units, and they're both as a unit rate. Okay. So which one is better? It's always when it's money, right? It's the cheapest. Okay. So Superstore is best. I'm gonna buy you just find the difference. So if you want to quickly do that, 3 cents. It's not just 3 cents, guys. It's 3 cents for every pound, right? You would save 3 cents for every pound that you buy because you're subtracting rates. So it's best by 0.03 cents per pound. This is your final conclusion there. So if you were to buy, 10 pounds worth of turkey or whatever, you can actually just multiply 10 times this and you save 30 cents. Right? Wow, it's not worth the drive, is it? That's beside the point. You make that decision as you go along. I want you to try a B before I move on. Which is faster? So traveling at this speed or that speed? Like which one is faster and by how much? Maybe to make things easier, I'm going to ask you to convert them both to meters per second. Okay? Or have both. So do this, I will say this in meters per second. So then that way you know I'm not going to convert this one. I'm going to convert to 50 kilometers per hour. That way we all kind of have the same thing, even though it wouldn't matter to me on a test which one you converted for instead. Okay. So convert the 50 kilometers per hour to meters per second and then figure out which one is faster and by how much. We're doing double I. Oh, it's still frozen. There you go. So if you're doing the next one, do it in miles per hour. Okay. I probably will only do one. So traveling this or this, I will maybe call this A and B, okay, just to distinguish. So I will pick that and I'll convert that, even though technically it wouldn't matter which one you converted. So for 1 hour, so we know that 1 kilometer has 1,000 meters. And so that will give us that. And then we also know that 1 hour has 3,600 seconds. Cancel the hours. We have meters and seconds left. So that'd be this many meters if you multiply as across, and you have 3,600 seconds, right? And now you get your unit rate out of that. So it's 13.89 meters per second. For MS, that's fine. So you would then have to say that, traveling at 14.2 meters per second is faster by, what is it, 0.31 meters per second? And so if you're wondering, where did he get that from, right? This is just an aside, but this is really the answer. Right? And here, and the answer key is posted, traveling at 20 meters per second is going to be faster by 14.74 miles per hour. Okay, so 20 meters per second by 14.74 miles per hour. It's just the answer in case you want to attempt that later on. Okay. I'm gonna stop here and just ask you to do for homework. You can start here though. No need to wait for homework. I'm going to ask you to do page 7. So page 7, technically, there's a chance that you can get it done in class, right? So that'd be page 7. So if you want to write down, in addition to that, pages 13 to 14, that's a worksheet. And it basically just walks you through some more conversions, okay? So I'm just going to ask you to try those, to be prepared for those. And so tomorrow's AC will have everything we've covered up until this point. I will look for the key and post it. And if you need help, let me know. But so it's a matter of converting and sometimes setting up a proportion if you need to figure out, if you need to predict what's going to happen down the road, right? So I'll leave you to it. And tomorrow we'll start doing renovations.